Out here's our issue. Are there two numbers exactly the same but multiplied to give us 196? Yes, there is. And here's how easy it is to find, because you wouldn't have any other way to do this except for a calculator right now. You take 1 and 196, you know that works, right? 1 works for everything. Then you'd have to take 196 and divide by 2 to see if it works, and 3, and so forth. Well, here's how you do this. You want to be careful and listen carefully what I'm telling you. It only works when this first term is a 1. You with me? If that were 2 right there, or a 9 like the other one, you can't do what I'm about to tell you. It only works when the first one's a 1. Take a look at the middle term, that's 28. What's exactly half of 28? There's the two numbers. 14 times 14 is 196. A lot easier, right? You would have been able to figure that out, but it was going to take a while for you to divide all those pairs out. And finally, you guys would have looked at this and said, okay, that's a plus. So these are either both negatives or both pluses. And I'm guessing it's both pluses because what's the middle term sign? So then you would have went to the next step and said, okay, Mr. Ever said, if there's no number in front of the first term, then those signs are the same. I'm looking for a pair of numbers over here that will not only multiply to give me 196, but add to give me 28. And you'll look down the pair and saw it, oh, 14 and 14, there it is. Was this not easier? Okay, but you've got to recognize you have to see it. I mean, there are ways to do it otherwise, but these are special ones that you need to recognize it so it makes your life a lot quicker, simpler, and for you to get the problem done easier. And again, if I want to check this, this is F, and the word FOIL, that is 1x squared. This is L, that's plus 14 times plus 14, that is plus 196. It's O and I I'm concerned with. O is plus 14x, I is another plus 14x. Those are like terms, they do add, and I do get the plus 28x in the center is exactly what I should have. So you need to get used to checking these. I've been watching your guys' homework paper as well as my other class, and rarely does anybody check anything. And if you do, you're not writing it down. All right, moving to the backboard. We're now looking at problem 36. Same questions once again. Is it a trinomial? Yes. Is it descending order power? Yes, it is. Okay, so our third question is, can I factor out a common number? Okay, so if I'm going to be able to do that, which number am I looking at? Right, the smallest number, the 4. So, there's the only two ways that I can multiply together to get 4. So if I'm going to be able to factor out a common number, it's going to have to be a 4 or a 2. Would you agree?
Yeah.
Okay, so let's look and see. Does 4 go into 4? Yes. Does 4 go into 36? Yes, it does. Does 4 go into 81? No, it doesn't. 4 is out. So now we're looking to see, can I factor the number 2 out? Does 2 go into 4? Sure. Does 2 go into 36? Yes, it does. Does 2 go into 81? No. Okay, so this one now, 36, looks like just what you've seen over there a minute ago. Are there two numbers exactly the same to multiply to give you 4?
Yeah.
Are there two numbers exactly the same to multiply to give you 81?
99.
Then we know what they are. This is 2q, this is 2q, this is 9, this is 9. What's the two signs?
Negative.
And why did you know they're both negatives?
The middle number.
Because the middle sign's negative. A problem that looked kind of complicated was relatively pretty simple. And these are the kind of things they throw at you on those OGT tests, the new AIR test, the ACT or SAT test that you guys might be taking if you're deciding you want to go into school somewhere. They look like they're complicated, should take a long time, but relatively they're not. If you know the little tricks of the trade, you can do it really fast. Now, we're not even sure that's right. Once again, you should be doing O and I and checking to make sure it's correct. We know F is 4q squared. We know L is plus 81. We chose those things to make that happen. Once again, we did not choose O, and we did not choose I. Those two things happen from the other things we picked. If we multiply, we're going to get a negative 18q. If we multiply I, we're going to get a negative 18q. Are they in fact not like terms? Q the first, yes. Are they addition because the signs are the same? Yes. So we're going to get a minus 36Q if we add them. Is that in fact the middle term?
Yep.
Then we've got it correct. It's just that easy. 42. I picked this one for a specific reason because this one's kind of looks like it's set up backwards. And somewhat it is. Is it a trinomial? Yes. Is it desyngular power? Yes. Is there a common number we can factor out? Well, we'll have to wait and see on that, but we're going to do that now. What number are we looking at? 3. Exactly. That's why I chose this problem, because we wouldn't always just pick the first number. It's the smallest of the 3 numbers you have there. Because look at the 3. If there isn't going to be a number 3 common to all of them, you're not going to be able to get anything common, right?
Right.
Okay, well, let's see. Does 3 go into 48 evenly?
Yes.
What is it?
16.
Good. Does 3 go into 24?
Yes.
And it is?
8.
Okay. And of course we know 3 goes into 3, right? So we are going to factor the number 3 out. Now you guys have seen this before. We're going to factor the 3 out, and then we got to find out what's left over yet that we can still factor farther. So what's going in the first spot there that multiplies to 3?
16x.
16x squared. That is right. How about the second spot?
8x.
What sign?
Positive.
Positive 8x. Are you guys seeing this?
Yes.
Or we've done this before. That's distributed property. And what about the third spot?
Plus 1.
Plus 1. I want you to take a close look. Are there 2 numbers exactly identical would multiply to give you 16?
Yes.
Yes. 4.
Are there 2 numbers exactly identical would multiply to give you 1?
1,
Yeah.
1.
So you know the answer to this problem now. And what about the signs between the 4x's and the 1's?
Both positive.
Both positive because the middle term's positive. Wow, isn't this pretty simple?
Yeah.
When we started this out, this could be very complicated, and this is usually tricky for everybody. And that's why Algebra 1 usually stops here. You might have seen it, might not have got to it, and Algebra 2 is normally where we start. Now once again, I'm not sure this is right. I've got a pretty good idea, but again, we should do O and I just to be safe. You don't have to write it down, just look at it. Right here's O, outside 2 terms. That was giving me a plus 4x, won't it?
Yeah.
I is the 2 inside closest together. The result multiplying there is a plus 4x, isn't it? So you got a plus 4x and another 4x. Those add and give you a plus 8x. Isn't that what we had? So we know we've got it right. You guys do remember this whole first part of this chapter, what we're doing is working backwards. You've been given the answer, you're trying to find the problem, because this is what you would have gotten in Algebra 1. They would have told you to take all of this right here and multiply it together by FOIL. And you would have multiplied these 2 together, FOIL, you would have got this, and you'd have turned around and multiply all 3 of them by 3s, and you'd have got that as the final answer. So we are working backwards. We took the answer, found the problem. 46. You can probably guess why I picked this one. Look at the numbers. Oh my gosh. This ought to be a nightmare. Same routine. Doesn't change for us. Is it a trinomial?
Yes.
Yes. Is it desyngular power? Yes. Can I factor out a common number?
Yes.
Well, I don't know. If there is, it's going to be what?
2.
All right, remember we're going to use the number 8. But remember, we start out listing our possible scenarios, and 8's the first number we're going to work with. All right, well, we know 8 goes into 8. Does 8 go into 120?
Yes.
Well, I don't know. Yep, it does. It's 15. Does 8 go into 450?
No.
I don't have a calculator in front of me, so that's not going to be 6. So that's 48. That'd be 5. That's 40. That leaves me 50. And no, 8 doesn't go into 50. 8's now rolled out. What number am I looking at next?
4.
Yep, my next largest one, the 4. I know 4 will go into 8 2 times. I know 4 will go into 120 30 times. I don't know about 4 into 450 though. And nope, it will not. So I've ruled out 8, I've ruled out 4. If anything's going to possibly be factored out, it's going to have to be a 2, correct?
Yep.
I can see 2 goes into 8 4 times. 2 goes into 120 60 times. And I've got 2 now into 450. Yeah, works.
25.
Okay, 225.
Oh, God.
Okay, so I'm going to factor the number 2 out. All right, so if I take that 2 out, what's going in this first spot?
4x squared
4x squared, good. What about the second spot?
plus 60x
Plus 60x. And the last one?
plus 2
Plus 225, yep. Are you guys truly with me? Do you see how I got all this and came up with that?
Yep.
If you don't factor that 2 out, this may be factorable. You may get it into 2 parentheses. The problem is, it's just like we said about fractions. If it said reduce it in simplest terms and you didn't take the largest number out, right, that was common, you won't be in simplest terms. And the directions here are always going to say factor completely, which means simplest terms. So you've got to take the 2 out. All right, now let's take a look at this. Are there 2 numbers exactly the same with multiply to give you 4?
Yes, 2.
Are there 2 numbers exactly the same that's going to give you 225?
Yes, 15.
Yes, 15. Okay, so I now know my 2 parentheses. And of course, what's my signs?
Positive.
They're all positives, and that middle one's positive, so these are both positive. All right, so I've got 2 times the 2 parentheses, 2x plus 15. Again, I want to quickly make sure O and I works out, because I know I chose them for F, I chose them for L, I didn't choose them for O. That looks to me to be a plus 30x. This is I right here. Looks to be like another plus 30x. And those 2 are alike, same signs, going to add, and I'm going to get a plus 60x. Is that what's in the center?
Yep.
And we have it.
Yay.
Okay, you guys should find this pretty simple. I mean, really, it's not complicated at all. The only time when you can't do these special cases with the binomials and the trinomials, then it's when you have to start just plugging numbers in and find the combination that works. We've already seen that. We've been through those. Right? And we have some